Okay, in this video, I'm going to work on a few problems from the worksheet today. Anything that I don't finish in this video, I do expect you to complete on your own for homework and submit it next time we see each other in class. Yesterday, we were working on problems that look an awful lot like 1, 3, and 5. In each of these problems, there was a missing b term. There was no bx value in our quadratic. And we said that if there was no b term, no middle term in this quadratic, then we can solve this using traditional algebra. First, I'll subtract 4 from both sides of the equation. Then I'll divide both sides by 8. And I have x squared equal to negative 4/8. Now we could move forward with this using the technique from yesterday, but I do want to point out that negative 4/8 is the same as negative 1/2. So that's what I'm going to show here. Now from our examples yesterday, we said that we're going to introduce the square root symbol, so we have to be prepared for two answers, both a positive and negative result. And since the square root symbol on the right side of this equation covers the entire fraction, we can actually take that square root symbol over just the numerator and the denominator separately. Now this numerator, the square root of negative 1, is the value I. Sometimes you'll have to reduce that on your own, but this one's just the defined value I. And the square root of 2, well, there's nothing we can do to simplify that. Even if I tried breaking that apart into a factor tree, there's nothing that can be done here. So we're just going to leave this one as the square root of 2. What that means for us is that our final answer simply would be, I'll show it this way. The final answer would be x equals the positive and negative I divided by square root of 2. And I think that would be a good solution to number 5. Again, number 1 and 3 are going to be completed in a very similar manner. Use your notes from yesterday to continue practicing with them. As far as moving forward in this class, the next type of problem that we'll encounter are quadratic formula problems in which our solution might contain an I, or imaginary number. So in a problem like 2 here, I think the first thing we should do is identify our A, B, and C values. And here again, I like to compute my discriminant right away as well. So the discriminant is supposed to be b squared minus 4 times a times c. And off screen, I just used a calculator to compute my discriminant. And it's interesting here because the discriminant comes out to be negative 96. Now, negative 96 doesn't have a nice square root, and when I fill this into the result in the quadratic formula, which would be the opposite of b plus or minus the square root of the discriminant divided by 2a, this negative 96 isn't going to simplify nicely. So right away, I'm going to use a factor tree to split this apart. And there are lots of ways that you can perform this factor tree, but I happen to notice that 16 goes into 96. In fact, 16 times 6 would equal 96. 16 has a square root, so I'm going to put a box around that on the factor tree. 6 does not have a square root, so I'll factor it into 2 and 3. So this tells me that when I simplify the square root of 96, I should have the square root of a negative 2, 3, and 16. I'm just looking at the remaining factor tree components, and I'm including the negative sign from the beginning. And I'm making a note of this, that the negative sign turns into an I on the outside of the square root, so that takes care of it. The 16 turns into a 4 on the outside because the square root of 16 is 4. That's why I chose the 16 here and put a box around it. I knew that would turn into a 4 on the outside. But the 2 and the 3 don't have a pair to work with, so those stay behind, and I'm going to call that 6. So when I've simplified my discriminant here, I've got 4i square root of 6. I can bring that back into my quadratic formula and simply report my final answer as this. The opposite of b plus or minus the square root of my discriminant, which I've just shown to be 4i square root 6, all divided by 2 times a, which is 4. We have a negative 4 plus or minus 4i square root 6 divided by 8. And the very last thing that we should do is, as we practiced last week, if we notice that there are any common numbers that divide these three coefficients, we should go ahead and perform that division. All of these can be divided by 4, so we'll do that. And I'm running out of room, but I'll go ahead and report my final answer here. After this number is divided by 4, I'm left with negative 1 plus or minus 1i square root 6. Remember, the number underneath the square root doesn't change. And 8 divided by 4 is 2. And we've got ourselves a nice final answer. A bit more complicated than the examples from yesterday, but our prior knowledge of the quadratic formula should help out here. The only difference with this particular process is that in simplifying our square root, the square root of the discriminant, we just ended up with an I value. That's the only difference between this and the quadratic problems from last week. Now, if we see a problem like number 4 here, we'll again do the same thing, but you'll notice that the equation is not equal to 0. So let's make sure that we make that happen first. And I've moved these two terms to the left side of the equation by adding 8r and adding 12. Now I'm going to identify my a, b, and c values, and I'll calculate the discriminant as well. And again, after identifying a, b, and c, and substituting the appropriate values into the discriminant formula, I find that my discriminant is negative 368. Now here again, the discriminant is going to be placed inside of a square root, so we might as well simplify this now. I'm going to take a guess here. I think 368 can be divided by 16 again, so let's check that. Yeah, it worked out pretty nicely here. So 368 divided by 16 is 23. So that tells me that 16 times 23 equals 368. And 23 is a prime number. It can't be broken down any further, so I'm going to put a circle there. And this tells me that the square root of negative 368 is a negative sign with 16 and 23. On the outside, this negative symbol turns into I, and on the outside, this 16 turns into 4, and the 23 has to be left behind. Now, even if you didn't notice that the number 368 can be divided by 16, you could have performed your factor tree analysis just like we've done in the past. Say 368 divided by 2, etc., and continued breaking down. You would have finished with this expression by the time you were all done. Now, if that's the result of our simplified discriminant underneath a square root symbol, then when it comes time to finding our final answer, well, this should be pretty straightforward. I need the opposite of b plus or minus the square root of the discriminant, which we just established here a second ago, all divided by 2a. Well, the opposite of b is the opposite of 8, plus or minus 4i square root 23. It's nice doing some of that work ahead of time. And all of this will be divided by 2 times 9. Now, you might recognize this and do the math in your head first. 2 times 9 is 18, so I'm going to show that here. And I'll also make a note that each of these numbers can be divided by 2. Each of these coefficients can be divided by 2. They have a common factor of 2. So after I divide negative 8 by 2, I'm left with negative 4. After I divide 4 by 2, I'm left with 2i square root 23. Again, the number underneath the square root symbol does not change. And 18 divided by 2 is 9. And we have ourselves a good pair of answers. So there are only 8 problems in this homework. I'll go ahead and finish one more. That way I've done half of them, and you will have to do half on your own. So I'll jump down here and look at number 7 next. Here again, I want all terms on one side of the equation, so I plan on moving the 7 to the left and the 4n to the left. I'm going to pause the video and do that math now, and you should do the same. After adding 7 to 5, I got the number 12. After subtracting 4n, I've got a negative 4n. So the next thing we should do is identify a, b, and c and calculate our discriminant. Please pause the video now and try this one out on your own. Check your work in just a second. And it looks like our discriminant comes out to be negative 224. So right away I'll perform a factor tree and try to identify the simplified form of our discriminant's square root. And I didn't catch it this time, any of the big square numbers, but there are a pair of 4s in this factor tree, and at the end we have a 7 and a 2. So if I were to rewrite the square root of negative 224, it will look like a negative sign with a 4, another 4, a 2, and a 7. There is a pair of 4s, so I know that's going to come out as a single 4 on the outside. The I value comes from this negative sign. So when we're done, we should have 4I and the 2 and the 7. Well, there was no pair in either one of those, so I'm going to multiply those back together and call that 14. So the simplified discriminant is 4I square root 14. So finally, our solution for n is the opposite of b plus or minus square root of the discriminant divided by 2a. That's the definition of the quadratic formula we were using last week. Our b value was negative 4, so the opposite of negative 4 plus or minus 4i square root 14 divided by 2 times a, and we said that a was 5 just a second ago. The opposite of negative 4 is positive 4 plus minus 4i square root 14 divided by 10. Each of these numbers are divisible by 2. So we should divide the common factor out, and we'll finish with 2 plus or minus 2i square root 14 divided by 5. That looks like a good final answer. So here again, please use these completed practice problems as a reference. Feel free to talk to one another in class today to work through this together and complete the remaining 4 problems on your own or with a partner. And hold on to this worksheet until we see each other in class next. We'll go over the final answers, and I'll collect this worksheet then. Thanks.